Before that, a little bit about where I work. I work at Texas Instruments, where open source is at the core of our culture, and we believe in a strongly upstream first strategy. So whichever projects we work at, as you can see, we work on a range of open source projects, including Linux, Zephyr RTOS, U-Boot, which is a bootloader. Every project out there, we always try to push our patches upstream so that anyone can just download them, compile for our devices, and just use it. About me, so I'm an embedded software engineer working at TI. I am the maintainer for the Arduino Core API for Zephyr. A little bit about that API. So how many of you might have used Arduinos at least once in your life, right? So when I was new to Zephyr, I found the Zephyr APIs honestly a bit difficult to catch on to. So I was like, hey, there must be some Arduino layer to it. I mean, Arduino at that point was really popular, so I was like, let's use something. But when I asked around in the community, sadly there was nothing. Then comes 2022, Google Summer of Code project comes into being, where I am given the opportunity to develop the Arduino Core API for Zephyr itself. So I ended up completing that project and becoming the maintainer for this module. As part of my full-time job, I work on power management in the Sitara portfolio of SOCs from TI. So this is a MPU class device which runs Linux and offers a few MCU cores as well. More on that later. Other than that, I do U-Boot and device driver development in Linux. So here are a few supported platforms today in Zephyr that are offered by TI. So the one you see here is a Beagle Play. The Beagle Connect Freedom was something that Vaishnav talked about in his talk. The board down there towards the bottom left is the Beagleboard AI64, and that is our SK EVM, which is based on AM62. So I had one board to give away. So take a wild guess. On the Beagle Play, we have Cortex A cores and Cortex M cores. So out of these two, which core do you think is supported in Zephyr today? Any guesses? Okay, you raised your hand.
Maybe both.
Yeah, you are right. So as of today, it's a great thing, but we support both the Cortex A cores, which technically are meant for running Linux. But if anyone wanted to run their application, Zephyr application on a Cortex A core, it is supported on this AM62 SoC. I'll now talk a little bit about Beagleboard.org for folks who might not have heard of this platform before. It is an open source physical computing solution which is aimed at robotics or personal manufacturing tools, for example. All of the designs from Beagleboard.org are fully open source, so you can just download the schematics, go through them, you can hack, and all the components are also available for anyone to manufacture compatible hardware. Some of the applications are a game console, robotics as I talked about, or even home automation. So a little bit about what heterogeneous architectures are. Basically, they are a system that consists of a host processor, which can be a Cortex A core, which may be running Linux or some high-level OS. And then there is also some multi-core accelerators or coprocessors. So it is an amalgamation of microcontrollers and microprocessors. So for example, in TI SOCs, we have a Cortex A53 or a Cortex A72 core. And then we have Cortex R5 core or Cortex M4 core that we call as the MCU cores. And the block diagram that I've shown here is of an AM62X SoC, which basically has a quad core Cortex A53. And then for a general purpose MCU application, we also offer an M4 MCU. So let's see what is the status of these devices in Zephyr. So the AM62X SoC is used on multiple platforms, like the Beagle Play from Beagleboard, then the SK AM625, which TI offers, and also the Phytech 5-core AM62 board. It currently supports the Cortex A53 core, as I talked about earlier, and the M4 core. And its applications mainly revolve around human-machine interfaces, HMI, retail automation, and any sort of general-purpose applications that you can think of. The screenshot that I've attached here are some of the pull requests that have been merged, which essentially add support for the ping control inside the AIM6X SOCs. That was thanks to one of the contributors, open source. So this was not even a PR created by TI. It shows that how the community has accepted this platform and is even starting to upstream support for it themselves. Then we also added support for TI AIM62X, which has more things like UART, for example. Here's again a list of things. So we added support for the UART driver. Then we also had to basically use something called as RAT for the M4 core to access the global memory map. So all of those drivers were upstreamed as well. And they came with their fair share of challenges. We didn't know which subsystem they would go into, etc. So you're really free to just open these PRs and explore all the sort of journey we went through while we were upstreaming these drivers. And most of this was sort of done as an internship project at TI. Next, we come to a little bit more beefier platform, if you will. That is the Beagleboard AI64. This has the Texas Instruments TDA 4VM SoC. This has a slightly more powerful Cortex A72 microprocessor, which is accompanied by Cortex R5 cores, which are again much more powerful than M4 cores. And it has a huge number of IOs. It is an excellent platform for rapid application development. And to add Zephyr support, we had done a Google Summer of Code project again last year, which was called Zephyr support for the R5 core on the AI64. So as part of the project, the aim was not really to upstream everything because Google Summer of Code offers only a limited timeline. But within the short period of time, it was even a great achievement for the student to get his first driver merged inside Zephyr, which was the GPIO controller driver for this SoC. Then we also added interrupt support, which is the TI VIM interrupt controller support. And a few PRs that were left out, which was the overall SoC support, which I've mentioned with the PR numbers. If anyone is interested, you can go ahead and take a look. And we also want to add more peripherals and controllers to Zephyr later on. We are hoping maybe if this year there is more interest in Google Summer of Code, we'll take this ahead, upstream more number of drivers, and let's see where it goes. Now, the question is why Zephyr, right? So Beagleboard being an embedded platform, it can leverage the real-time capabilities of the Zephyr RTOS, especially for time-critical applications, like you have robotics or IoT devices or even industrial automation. Second thing, it is an open source project. So it's like an open source project helping each other, which is where we get a very active community of developers and contributors helping each other. The second thing, that many people have already talked about, the existing support for the variety of architectures that is there in Zephyr. For example, we got ready-made support for ARM and ARM64. So the overall effort to then port the ARM SoCs is kind of greatly reduced on this RTOS. And one of the most key aspects, Linux-like structure. So any Linux experienced developer finds it much more easier sort of to ramp up on Zephyr, especially because of the device tree structure and even the way Zephyr is organized, to start writing his own RTOS driver, and it really helps them develop faster. So here are a few references. It's the upstream documentation for the platform that we have upstreamed. Then there's a GSOC final report, and of course beagleboard.org. I'd like to thank them for organizing the giveaway again, and credits to TI, the Linux Foundation, for organizing this event, and Beagleboard again. Any questions?